Hi, so we're going to discuss the straw problem today and find a solution for that. So the straw problem is the following. If you take a length of straw here, right, my assistant Millie is holding, and if we were to pick 2 points at random along the straw in which to bend it, it's true that sometimes we could make a triangle. Show me how you can make a triangle. Hold it up so they can see. There, right? If you pick at those 2 points, but not every 2 points works. Can you show me 2 points where you can't make a triangle? That's right. If they're spread too far out, we can't make them join up. So the question is, if we pick 2 points at random across the straw here, what are the probability that we can actually form a triangle? Right? And that's what we want to solve. All right, so how is this a calculus problem? Well, it's really a random variable problem. We've got 2 random variables because we've got 2 random points. So to model this behavior, let's take our length of straw here, and we'll use the number line, of course, 0 to 1 as our model for the length of straw there. Then the 2 points at which we bend the straw, we can label x and y, and those will be our random variables here. So now it's a multivariable problem because we've got 2 random variables and a sample space of where they can occur. Each can occur between 0 and 1. And then we have an event, which is when these things can be bent into a triangle. Right here. So this example that's written here just does work. Right here. And when I pick another 2 random points here, this one's not going to work. The little one over there is so short, it doesn't happen. Okay, so we need to model our probability density function here. And so there are a couple different ways of modeling it, but I'm going to choose where we're going to call the lower variable x and the bigger variable y. And it's a little different than 2 independent random variables because we're going to say that x has to be less than y. So we just label them that way. And therefore, our probability density function is going to be some constant where 0 is less than x is less than y is less than 1, right, in our for 2 ordered points along the straw, and 0 everywhere else. So really our sample space is just this region up here, or you can think of our function as being non-zero only on that region. Now that number c, of course, is easy to compute. We have to ensure that our integral is 1, so c, of course, just has to be 2. Here's the region in question. Y is bigger than x. Here, of course, it has area 1/2, and therefore to make the integral equal to 1, the function has to be 2 on that region. Okay, so what makes an event, what makes a pair of points able to form a triangle? Well, the key, of course, it's just the triangle inequality. Right? The sum of 2 sides must be longer than the third side. Go back to our picture of the straw here. Right. Let's see what our 3 sides are. So, right, recall that if we make this point x along the line, this side length would be x, and then this side length would be y minus x, right here, and this last side length would be 1 minus y. And so therefore we get 3 inequalities out of the triangle inequality. I can make a triangle when the sum of any 2 sides equals the third side. So that's easy enough to model and evaluate. The first 2 sides, x plus y minus x, is greater than 1 minus y. But we can simplify that. That just means y has to be bigger than 1/2. Right? If both points are on the first half, we can't ever make a triangle. Here, right? And the second side is y minus x. That should be a minus sign. Let's fix that before we forget. Here, y minus x plus 1 minus y is greater than x. And again, right, the y's cancel, move the x over. Right, we see that x has to be less than 1/2, and that makes sense, right? One has to be on 1/2, and the other has to be on the other half, or else we have no hope of working. And the last one is simply the two other ones. X plus 1 minus y has to be greater than y minus x. And that can be easily solved, move the x around, etc. So y has to be less than x minus a half. So these three inequalities define a region in space. That region is called an event. Right? So we'll call that delta here because it can make a triangle. And we can visualize it easily enough here. So here's my sample space. So I'm going to, again, I'll do good old fill between right here. And I'll define x to be a linear space from 0 to 1. So I want to fill on the x-axis. Remember, y has to be bigger than a half. Right? So I'm going to do y to 1. All right, so that's the upper half. Well, let me make it transparent so that we can work better with this. Visualize this a little bit better. There we go. So now we want to be on the upper half plane, and just to make it clear that we're right, have the event. So now y has to be bigger than a half, right, is represented by this darker section up here. And if we do that for the other two inequalities, there. So I'm going to fill between x now, and instead of 1/2 to 1, I'll make it from 0 to a half. Right there, and so now we have to be on this side and this side. You can see that our space of possibilities for making a triangle is shrinking. And then for the last business here, remember that x has to be less than x plus a half, right? And by default, it will shade down to 0. And so when I do that now, right, we get another shading here. And so the result is all three inequalities have to apply. Our event space, therefore, where you can make a triangle, is just this inside here. All right. So that's what I called the region delta. And as I mentioned now, the integral becomes trivial. All I'm doing is integrating, right, over delta, the function 2 dA, right, will give me my probability, right? But I know what that is. That's just a fourth, right? Trivial there. So the probability of being able to bend a straw is a fourth, and that's it.